In this recording, we're going to figure out how to find the area of a triangle using trigonometry. As the objective says, we're going to try to find the area of a triangle that's an oblique triangle. That means a triangle that doesn't have a right angle, or for which we don't know the height. As you can see in the two triangles that we have pictured here, it's easy to find the area using the 1/2 base times height formula that you learned in middle school. Okay, if you know the height, you know the base, just multiply them and divide by 2. Same thing if it's a triangle like this, and you know the height. Easy to find the area. However, we're going to extend that formula to triangles that do not have a right angle, or for which we don't know the height. So let's consider this triangle. Okay, so in your notes, I'd like you to make a sketch of this triangle and think about what dimensions you would need to know to find the area of triangle ABC. Keep in mind, when you're sketching your triangle, we use capital letters for the vertices, those are the corners. We use lowercase letters for the side lengths, and it's always the side length opposite the angle. So angle A is across from little side A. I'd also like you to sketch the altitude of the triangle. Label it H. Okay, of course an altitude forms a right angle. So play the recording when you've made the sketch and you've thought about what you would need to know to find the area. Okay, so hopefully you considered, well, we could find the area pretty easily if we knew the A value and the H. We would just multiply those and divide by 2. However, we don't always know H, but sometimes we know a length A, a length B, and an angle measure C, the angle between them. Okay, so we're going to derive this formula together. I'd like you to use some color. If you have some color in your pen bag, color in the outside of that triangle like I did in red. I want you to write an equation that represents the area of that triangle. Then play the recording. Okay, so hopefully you wrote that the area, which we're going to use the letter K to represent because it's a constant, is 1/2 the base, which is A, times the height, which is H, so 1/2 A times H. Next, I want you to go back to your trigonometry knowledge. I want you to write an expression that involves this angle and this side and this hypotenuse. So in other words, we can't do anything with the A because the A is not a length of this triangle. We do have an angle C, so think about, would you use sine, cosine, or tangent, and then write an equation that involves H and B. Play the recording. Okay, so hopefully you wrote sine of the angle, sine of angle C, is equal to the opposite, which is H, over the hypotenuse, which is B. Alright, at this point we're just going to get the H by itself, because we really want to get rid of the H. So we're going to multiply both sides by B. We've got H is equal to B sine C. Now we're ready to do the magic. We're going to make a substitution right here into that original equation. So H is equal to B sine C, so I can make a substitution in place of H, and now I have a formula that does not involve H. It is the following. Area, which is represented by K, is 1/2 times A, but instead of H here, I'm going to put what H is equal to, B sine C. So 1/2 AB times the sine of angle C. And this is available on your reference sheet on your green book. It will be available on your Regents and on your unit test. Just need to be able to know how to use it. Okay, so I'd like you to formally write this definition. The area of an oblique triangle. An oblique means any triangle, not just right triangles. It's the product of 1/2 and 2 sides and the sine of the included angle. Okay, we write this formula because it's general. It doesn't refer to particular letters or particular sides. It's any 2 sides and the angle between them. If you know that information, you can find the area. How could you extend this idea to create a formula for the area of a parallelogram? Okay, think about that and play the recording when you've got an idea. Okay, so hopefully you said, well, a parallelogram is really just 2 congruent triangles, so I could consider this triangle, know the 2 sides, the angle between it, then just figure out the area of the red triangle and multiply by 2. Alright, we're going to do 2 examples to make sure you've got it. Okay, given this oblique triangle, where you have 2 sides and you have an angle in between, I want you to find its area round it to 3 decimal places. Okay? So first off, we're going to get out our formula. We're going to multiply 1/2 times the two sides, 12 and 18, times the sine of 94 degrees. Make sure your calculator is in degree mode. Enter that expression. Figure out what you get. To 3 decimal places, you should get 107.737 square units. We always want to put the unit on there, and of course it will be square units. Pretty useful formula, especially because we don't know the height here. Last example involves a parallelogram. Okay. I want to find the area of this parallelogram to the nearest hundredth. Again, we have two sides. We have an angle in between. So you'd work this one on your own, then play the recording when you've got your answer rounded to the nearest hundredth. Okay, so hopefully you've considered that it's really just two triangles. So if I could find the area of the red triangle, I could double it, get the area of the purple parallelogram. So if you haven't worked it out yet, work out your area of the red triangle, then play the recording. Okay, the area of the red triangle is 1/2 times the two sides, 10 times 16, times the sine of 60. Put that in your calculator. Got your answer. Double that. That gives you the whole parallelogram. And it should be 138.56 square units. Thanks for watching.